Look out the window of a cruising airliner and you're soaring at altitudes of 35,000 feet or more, far higher than Mount Everest. Outside, the air is thin, cold, and barely breathable. Yet inside, you're comfortable, breathing normally, perhaps even sipping a drink. How does this metal tube, hurtling through the stratosphere, maintain an invisible bubble of breathable air, keeping you safe and cozy miles above the Earth? It's a marvel of aerospace engineering, a constant, precisely controlled battle against the vacuum of high altitude. It's a silent, life-sustaining system that makes modern air travel possible. Welcome to the Smart Side, the channel where we unravel the ingenious science and hidden processes behind the everyday. Today, we're taking a high-flying dive into the fascinating world of cabin pressurization, revealing how airplanes keep you breathing easy at cruising altitude. To understand how cabins are pressurized, we first need to understand why it's so critical. As an airplane climbs higher, the air outside becomes progressively thinner. At 35,000 feet, the air pressure is a mere fraction of what it is at sea level, and oxygen molecules are far more spread out. For the human body, this presents a severe danger: hypoxia. Without enough oxygen, our blood can't deliver what our brains and organs need. Symptoms can include dizziness, confusion, impaired judgment, and rapidly unconsciousness. At typical cruising altitudes without pressurization, a human would have only seconds or a minute of useful consciousness before succumbing. This is why airplanes must fly high. They're more fuel efficient and can avoid bad weather, but humans cannot survive those conditions unaided. The solution lies in creating a simulated lower altitude environment inside the aircraft. This process begins with the very engines that propel the plane forward. Modern jet engines are incredibly powerful air pumps. As they suck in and compress vast amounts of air for thrust, a portion of this highly compressed superheated air, called bleed air, is ingeniously diverted. Newer aircraft like the Boeing 787 Dreamliner use electric compressors instead of bleed air for even greater efficiency, but the principle is similar. This hot, compressed air is then routed through specialized equipment called air conditioning packs. Here it's meticulously cooled, filtered to remove contaminants, and often humidified to a comfortable level. This conditioned air is then continuously pumped into the cabin, creating a constant inflow. Think of the cabin as a slightly leaky balloon that's always being inflated. Pumping air in is only half the battle. To maintain that perfect, stable cabin pressure, excess air must also be precisely released. This is the job of the outflow valve, often a large, movable flap located near the rear of the fuselage. The entire system is orchestrated by the Cabin Pressure Controller, or CPC. This dedicated computer constantly monitors the actual air pressure inside the cabin and compares it to the desired pressure, usually equivalent to an altitude of 6,000 to 8,000 feet, which is comfortable for most humans. If the pressure gets too high, the CPC commands the outflow valve to open slightly, allowing some air to escape. If it gets too low, the valve closes slightly, trapping more air. It's like precisely adjusting a bathtub's drain plug while the tap is running, maintaining a constant water level. This continuous, intelligent adjustment keeps the cabin pressure remarkably stable, even as the outside pressure changes dramatically during climb and descent. Because cabin pressure is so vital, backup systems and fail-safes are built into every design. Pressure relief valves. If the outflow valve were to fail and too much air was pumped in, these safety valves would automatically pop open, preventing the cabin from overpressurizing and potentially damaging the fuselage. Negative pressure relief valves. Conversely, if the outside air pressure suddenly became higher than inside, perhaps during a very rapid descent, these valves would open to prevent the cabin from being crushed. In the rare event of an unexpected rapid loss of cabin pressure, a decompression, the system is designed to react instantly. Pressure sensors trigger alarms, and those familiar oxygen masks drop from the ceiling, providing life-sustaining oxygen until the pilots can perform a rapid emergency descent to a safer, breathable altitude, usually below 10,000 feet. It's a testament to the layers of invisible guardians always watching over you. So the next time you're soaring through the sky, remember the intricate ballet of engineering that keeps you comfortable. From the powerful engines providing life-giving air, to the clever outflow valve precisely balancing the bubble, and the redundant safety systems always on guard, every element works in perfect harmony. It's a silent miracle, transforming the thin, unbreathable air miles above Earth into a safe, cozy environment, making modern air travel possible. Were you surprised by the hidden science behind airplane pressurization? What other flight secrets or invisible technologies do you want us to unravel on the smart side? Share your thoughts and curious questions in the comments below. If you found this explanation enlightening, smash that like button to support more smart content. Share it with a friend who loves to fly, and make sure to subscribe to the Smart Side for more mind-blowing discoveries. Stay smart and enjoy your next flight.